All right, geometry. We are moving on to 7.3. We'll discuss more on 7.2 in class, but 7.3 is similar triangles specifically, and it's very similar to proving triangles congruent. There's three different basically theorems that we can use, and the first one we're going to talk about is angle-angle similarity. Okay, so what this means is if you know two angles. Okay, if two angles, corresponding angles that is, if you know two corresponding angles, I'm going to write in lowercase, there we go, two corresponding angles are congruent, this was hard to write. Sorry about this. Okay. Corresponding angles are congruent. If you know that, then the triangles are similar. Goodness, I am struggling. There we go. Okay. So, if you know two corresponding angles are congruent, then you know the two triangles are similar. Okay, that proves it, because if you know two corresponding angles are congruent, then all of the angles are congruent. Okay, so let's look at a couple of these here. Number one, we've got these two angles are congruent because they're vertical, and then if you look at the other two, these are perpendicular lines. Okay, so that means if they have a transversal, which these do, then alternate interior angles are also congruent. So angle C and angle G are congruent. Okay, so if we were to say, for instance, triangle CDE, that is similar to triangle, and this is where you got to really pay attention to the order. C is corresponding to G. D corresponds to F, and E equals E, so that is E. Okay, now that's not angle E, but the E point or vertex goes together. Okay, that's it by angle-angle similarity. All right, so kind of the same thing on number 3. Looking up number 3, we've got a right angle here and a right angle here. And then it says 39 here. Well, if you think about triangles, you've got 39. Well, what is this angle going to be? Well, 90 plus 39 gives us 129. And so 180 minus 129 gives us 51. And so if that angle S is 51, C is W is also 51. And so those are similar. So let's say I start with S. S, Y, E. So that's the first triangle. So S corresponds to W. So triangle W. And then Y goes with C. So WC, H. By angle similarity. Okay? And so, last one here, and then we'll look at the next theorem. Number 5, same deal. We've got two triangles here, small one and a big one. Okay, so if you think about it, this big triangle, angle N is 67. And then if you look at the small triangle, angle N is still 67. So we've got 67, congruent to 67, and then I don't know what this is, but what I do know is 91 plus 67 in the small triangle is 158, and so 180 minus 158 is going to give us that other angle, which is 22. Well, look at the angles we have. I've got 22 here and 25 here. So since those are not the same, these are not similar. Okay, only found one angle that was the same. Okay, and that's it. Okay, we can do those other two, but we'll do those later. Okay, so look at the next one is side-side similarity. Okay, now this is different from side-side congruency. Okay, because this is saying if three corresponding sides are proportional, not congruent, proportional, then the triangles, then the triangles are similar. Okay, so all three have to be proportional. So when you look at these, I'm seeing the biggest with the biggest, the smallest with the smallest, and so on. Okay, so as I look at this first one, number 7, I've got the smallest one is 9. The smallest one over here is 14. So 9 over 14. Well, just so we get the same thing every time, 9 divided by 14, or 9 over 14, is 0.64, rounded. And so the second largest of the first triangle, 13.5, and the second largest over here is 21. Well, 13.5 divided by 21, still 0.64. Okay, and then now the biggest, that was second, and now the biggest, 20.25 over 31.5. 20.25 over 31.5 is also 0.64. Okay, so since all of those are the same proportion or ratio, that means these are similar. So triangle, I'm going to start with N. So NKR is similar to triangle, and think about what N goes with. N goes with E. And then NK is the smallest one, so EDS would be our other triangle by side similarity. Okay? So not only do you need to provide your triangle similarity statement, but also the reason, side similarity. Okay? So let's look at the next page on the back. Look at a couple more of these. So number 9, I've got the smallest one, 5, the smallest one, 4. So 5 over 4, okay? And then we've got the second largest is 12 and 10. Well, 12 over 10, that would reduce, oh, I did the wrong thing, didn't I? So 12 over, not 10, but 12 over 7. Well, think about this. Does 12 over 7 reduce to 5 over 4? It does not. Okay? So 12 over 7 is not equal to 5 over 4, so therefore not similar. Not similar. All right? And so the last one here, I've got excuse me, the smallest one, 5 and 9. So 5 over 9. I've got 13 over, oh, actually, I don't know what that last one is because these are not the same thing. So in this case, we got to use the Pythagorean theorem. Okay? So in that first one, it would be, let's go ahead and find that first before we start looking at those. So 5 squared plus x squared equals 13 squared, using the Pythagorean theorem. So that's 25 plus x squared equals 169. subtract 25, yeah, x squared equals 144. And so that x equals 12. So this is 12 here. And then same thing on the other side. 9 squared plus 21.6 squared equals, we'll call that y, so y squared. So 81, 21.6 squared is 46.56 plus 81. So y squared equals 547.56. Square root both sides, we get y equals what? 23.4. Okay, so 23.4. Now we can go ahead and look and see if all of these are proportional. So 5 over 9 is our first one. 5 over 9 gives us 0.5 repeating. Okay? And so the next biggest one would be 12 and 21.6. So 12 over 21.6 is 0.5 repeating. Okay? And then the last one, 13 over 23.4. 13 over 23.4 is also 0.5 repeating. And so therefore, let's write out our triangle statement. Triangle, I'm going to go XYZ. XYZ is similar to triangle. X is the nearest point, so V, XY, Y is the right angle, so that's WR. And that is by side, side, side similarity. Okay? All right. And so the last one we have here, the last theorem, is side angle side similarity. So if two corresponding sides are proportional and the included means the one between the included angles are congruent, then the triangles are similar. Okay, so let's look at a couple examples of that. In this case, I've got 6 and 24. So 6 over 24 reduces to 1 over 4. And 12 over 48 is also 1 over 4. Now, what's the included angle? This is where we got to understand one at a time. That's the included angle here, and same deal. That's the included angle here. And we know those are congruent because of vertical angles. And so, angle SER is congruent to angle FEG. Therefore, we can say, okay, triangle, let's start with the bottom one. SER is similar to triangle, and then S was going with 48, so GEF. By side angle side similarity. Okay. So, look at the same thing here. Number 15. I've got 22 and 36. So 22 and 36. That reduces to 11 over 18. And then if I just wanted to get the decimal, it would be 0.61. And then 33 over 54 is also 0.61. So those two are good. Those are proportional. Now, look at these two angles. The angle between them is angle M and angle P. Now, how do I know those are congruent? Because these are parallel. So if they're parallel, you can see these are the parallel lines. Here's your transversal. Those are corresponding angles. So angle M is congruent to angle P. And so therefore triangle, I'm going to start with C. CMP is similar to triangle. C goes with R, so RPQ. And that is by side angle side similarity again. Okay? And so the last one here, we've got two triangles once again, small and the big. I've got 15 goes with the whole thing. Okay, you got to understand this is the whole triangle and the small triangle, not this trapezoid. Okay, so the whole thing there is 45. So that'd be 15 over 45, which reduces to 1/3. And then 14, and then the whole thing would be 28 plus 14, which is 42. So 14 over 42, which is also 1/3. So those are good. And now think about the included angle, which is going to be right here, angle W. And obviously, angle W is congruent to itself by reflexive postulate. So, therefore, triangle, I'm going to start with the big one. WSZ is similar to triangle W again, QR. By side angle side similarity. And there we go. That is similarity statements, similar triangles. Okay? So you got some practice, and get on that and make sure you're done with your knowledge checks. Peace.